All right, class. So in the last class, we had completed the gravitation. We had started with the gravitation and we had completed acceleration due to gravity and its variation. So today we will start with gravitational field, potential, field intensity. These are small, but important topics that the questions do come from these. Now see, first we'll start with gravitational field. Potential we'll see later on. So see class, gravitational field and all these, let me tell you. See, again, you will be having the whatever I have told you, you study in gravitation, same things you have to study in class 12. So these topics are also very important. So gravitational field. Okay, now see class. Let's say this is some area that I have confined. Now let's say at the center of this, I have let's say this is Earth is there, radius r is there. Now this is the space that is confined by this. There's a certain space. Now whenever I am bringing a test mass near it, any mass, when the mass is here, I'm not able to feel any force. All right, at this point, let's say at this point, at A point, I'm not able to feel any force. When I take it at B point, exactly at this vicinity, what is happening? I'm able to feel a certain force that is exerted. So this confined area which you observe, this confined area here, this one, this which I have drawn, this confined area where you're able to exert and where the space around any mass where you're able to feel the gravitational force, that is known as gravitational field. So this is your source mass, and this is the test mass. Fine. So what is gravitational field? It is the space around a mass in which its gravitational force exists. So exactly now, even if you take the mass here, if you keep the mass a little closer, still you'll not be able to feel any force until and unless you step up on the space or inside also. Inside, to definitely you will feel, let's say at this D point. So see, different points you have, A, B, C, D, all the 4 points you have, right? And it's a property of at least one mass. One mass has to be there to exert gravitation. So it's a property of at least one mass. Now see, if I take this entire force, the gravitational force, let's say that is getting exerted, and I divide it by the unit mass, means gravitational force per unit mass if I want to find out. So that strength, do you see that strength that is there of the gravitational field which you see? That quantity is known as gravitational field intensity. This is known as gravitational field intensity. This is known as gravitational field intensity. So gravitational field was what? Gravitational field was basically the space around where you feel the forces that are occurring, right? When you take that force for a single unit mass, like this is represented by I, the entire gravitational force per unit mass, that is known as intensity. So it basically measures the strength of gravitational field. It measures the strength of gravitational field at a point. Fine. So I formula, this intensity's formula will be F by M. SI unit will be what? Newton per kg. Newton per kg. Because force is Newton, mass is kg. Fine. Now, if you want to find out gravitational field for a point mass, do one thing. I think note it down till here. Then we'll discuss it. First, note it down. Now, gravitational field for point mass. Gravitational field for point mass. Now, C class. If you have point masses, means for spheres also these are valid. If you have point masses for spheres, even if you write, or generally for two particles. So see here, let's say you have a source mass. Source mass means on which the force is exerting or not we are testing. And because of which the force is exerting or not that we are testing is test mass. So test mass and the source mass. Let's say both of these are separated by a distance r. Small r is the separation between them. Now see, force will be what if you apply gravitational force. So gravitational force will be Gmm by r square. Right, gravitational force will be this. And also intensity will be force divided by mass. So gravitational field for point mass. This becomes gravitational field for point mass. That will be Gm small m by small m r square. So mass of the body gets cancelled. Intensity becomes Gm by r square. This is the formula of. Had it been the radius of Earth, the formula would have been similar to acceleration due to gravity. Remember, capital G into m by capital R square. Anyways, now C class. So let's practice some question first on this. Then we'll see things later on. Let us just see a numerical on this. So question is, you have a 2 kg body. Fine. This is 3 meters. At this point P is present. You have to calculate gravitational field at this point P. So calculate gravitational field at P. At this point you have to find out. Now see, intensity, gravitational field intensity is Gm by r square. G is gravitational constant, 6.63 into 10 to the power minus 11. Mass is given to you as 2 kg. So 2 divided by r square, that is square of 3. So this will be around 12.2 something, no? 12.2. Let's take it as 6.6 then. 12.2 into 10 to the power minus 11 by 9. Approximately you will get this much Newton per kg. This is what you will get. Now see here, direction will be towards the body, towards the mass, because gravitational force is attractive. It is not repulsive force. So even if you want, you can put the unit vectors like minus I cap you can. All right. Note it down. Okay, one more thing. Class C, the rod relation we did. Remember one, just make it a note point and write it. One rod question we had seen. Rod was there. We took dx, dm was the mass per unit length. Remember one question we have done like this for variable part, right? So see, here this is not valid. You cannot perform this Gm by r square. This is not valid because rod is not a point charge. So if you get such questions, they do not apply gravitational field intensity. You won't get questions on this only, rod and something else, any rigid body, big body. It is just applicable for point masses or spheres. Spheres also can be considered. You can calculate the field outside the sphere. Same thing, Gm by r square. Fine, note down this. Then one more thing you have here within this topic only, I'll tell you. First, just note it down. This is not a very big topic, easy, small topics, and questions are also direct. From gravitations, the questions are not difficult that come. Questions will be much more difficult from rotational. So class, keep on practicing rotational dynamics. All right. Keep on practicing it still. See class, superposition principle we did. Can anyone repeat superposition principle? See, superposition principle is always valid when you have more than one mass. So let's say this is one mass M1, this is one mass M2, this is another mass M3. There will be so many masses, let's say Mn, nth mass. And at this P point, I have to calculate now the gravitational field intensity. So now how will I calculate? I know that this separation is R1. So I know I1 will be Gm by R1 square. Fine. Not Gm1. Mass is also given. No, here. So this will be G small m1. Then let's say the separation with this is R2. So I2 will be G m2 by R2 square. Separation with m3, this is R3. So I3 will be G m3 Rn wholes, R3 whole square. Let's say nth is there, that is Rn. So nth will be G mn by Rn square. So I have so many intensities right now with me, I1, I2, I3, I4, I5, I6, like this, depending upon the number of mass. So final intensity will be the vector sum of gravitational force due to individual intensities. Like I net will be I1 plus I2 plus I3 plus IN. This will be IN. Fine. So how this is not the algebraic sum. It's not like you have I1 as 3, I2 as 4. So you will add 3 plus 4. No. Vectorically, you have to add it. Parallelograms, no law and all these laws, vector laws you have studied. So same laws you have to apply over here. All right. So how will you write it? This is basically net field at point P is due to individual, or it's better if we write in some P is the vector sum of individual intensities. Fine. So I will be I1 plus I2 and all till INth. All right. Now one thing class, if you have a symmetrical distribution, suppose you have some symmetrical distribution. Symmetrical distribution means geometrical figures that are proper. Like if we talk about a proper circle. So if we talk about a proper circle, this is a symmetrical figure, right? The circle, this is a symmetrical figure. Now see, at the center, if you calculate of the symmetrical figure, so always remember at the center gravitational field intensity, it will be 0. Here I will be 0 at the center. Let's say if you have a triangle, let's say. If it's an equilateral triangle having, let's say, sides AAA in all the direction, right? So this at the center, it will be equal to 0. Any figure, any shape that you have, even if you have square with you, so let's say square will be having all the sides equal. So at the center of the square, intensity will be 0. Why am I saying? Because if you get questions where multiple intensities are required, then do not get confused. At the center, if it is asked, directly use it as 0. Write it as 0. Noted down one question, one very important question is there where gravitational field is calculated between the 2 points, the two masses that we'll see. First, tell me, till this point, is it clear gravitational field intensity? I is equal to gm by r square. R is the separation. One mass is required whose gravitational field you are calculating. SI unit is Newton per kg. You cannot use it directly because it's a vector quantity. So you have to apply all the vector laws and then you have to add it vectorically. And it is given by again the same superposition principle. For symmetrical figures at the center, make it at the value of intensity becomes 0. Is it clear till here to all?
Yes, ma'am.
Okay,
Yes,
then
ma'am.
note it down. See, how will we solve this question? At this line, you have to find out a point where the gravitational field is 0. So 2 kg mass is there, 5 kg is there, and total separation is 10 meter. Now, at this point, let us assume, let us say P point is the point where gravitational field is 0. So let's say this distance is x. If this distance is x, let's say this is AP. AP is x. So what will be PB? This separation is x. Yes, Tareen.
Ma'am, 10 minus x.
Yes, 10 minus x. Now see, at this P point, it is 0. It means whatever is the gravitational field intensity because of A and B, that is 0. So you can say A, both the intensities are equal. That's why it is getting cancelled and it is 0. So A will be what? Gravitational field intensity at point P because of A. So what is the formula? Gm by R square, not capital Gm by R square. Now see, so capital G, mass for the first one will be 2. Separation, radius, this is x square, equal to IB. See, gravitational constant G, mass is 5 for B, and separation is 10 minus x whole square. G gets cancelled. So what we'll be left with? Make this as 6 kgs. Otherwise, this answer will become more confusing. This is 6 kgs. So this here also we'll have 6 kg. So 2 and 3, at least we have 3 over the side. Or you can do one more thing. Make this in terms of root only so that you can get a better answer, because here you won't get a definite answer. Let's write it in terms of the roots that we're getting. Now see, we just have to solve this further. So GG got cancelled. For the root part, take the root on both the sides. That becomes root 6 by 10 minus x. Cross multiply. So if you cross multiply 10x with root 2, which will be equal to root 6 into x. Now open up the bracket. So root 2 in 10 root 2 minus root 2x is equal to root 6x. So 10 root 2. Let's bring the terms having this x together. So 10 root 2 will be equal to root 2x plus root 6x. Take x common from here. 10 root 2. If you take x common from here, you will be left with root 2 plus root 6. So x will be 10 root 2 by root 2 plus root 6. Now from the final answer, if you wish, you can take root 2 common and simplify it further. Like this you have to solve. All right. Note it down, class. Class, one more type of numerical come from this. In that, no, you have, I hope you have written till here, all of you? Written?
Yes, ma'am.
Okay, okay. See, one more type of question that comes from this part is, no, one is the simple formula based. You will have squares, cons squares, you will be having four masses, like that questions will come. The different type of numerical that could come is this, find out where it is zero. One more type of question that comes, let me write down the question. See, if you do it by the original method, that is the conventional method, then it will take a lot of time. I'll just tell you. Let me write the question first. See, class, in this question, you have a pentagon. Fine, you have a pentagon. But on the, if all the 5 points have been, all the 5 vertices have been filled by point masses, then at the center, if you are asked to calculate gravitational field, according to you, what should have been the answer if all four were filled? Any idea? Just now we had discussed something. Yes, class. Let's say one mass is over here, another mass is kept at this point, another mass is kept at this point. All the 4 points have been filled, suppose. Now, if all the points are
जैसे पोछा लगाती हूँ उससे हमको किचन में ही पोछना चाहिए था।
C class. Now my screen is sharing with you. Just check.
Yes, ma'am.
Okay. Now see, IA, IB plus IC plus ID. Had there been any point mass D on this point D, then ID plus IE at the center, it would have been 0. But right now, you don't have ID. You have only 4-point masses given. So how will you calculate now? C class. If all the 4 are calculated for single point mass, you'll get it for the entire. So see, IA plus IB plus IC plus IE, this is actually equal to ID only, because then only all the sum whatever 4 intensities you're zero. So when all the 4 will be having the value ID, which is equal to gm by r square only. Let's say the separation is a, so that becomes, and mass is m, so that will be g small m by a square. So for proper calculations, a, m, MA, all these things. If you calculate and write it, then you will get answer at the end only. It would have compensated at the center, it would have been 0. But since D is not available, it means all the 4 values are negative of D point. That's why you are having the value. We are not concerned with the magnitude. That's why we are just putting it as plus, just taking the magnitude of all the values. Tell me, class, is this question clear or you have any doubt in this?
Clear, ma'am.
Clear? Do you want me to repeat what? Okay. Note this question as well. See, gravitational field, when we have to calculate it for spheres. Spheres case, let's see, gravitational field. So see, for hollow sphere, if you have a hollow sphere, then see, suppose you have a hollow sphere at a particular P point you're calculating, the radius is R. And this radius, this entire separation from the center to that point, I'm taking it as small r, mass is m. So see, for hollow sphere, there will be three cases. One will be outside like this P point. This P point is lying outside. So intensity will be what? G m by small r square, right? This is the separation. Mass is this, G is this. Suppose I say exactly at the surface I am calculating. So can you tell me what will be the value of small r on the surface? Value of small r on the surface if the point mass is here. From the center, what is the separation at the surface? Yes, class. Are you there, present or not? Yes, no, what?
Yes, ma'am.
See, class, from the surface to the center, what do we call this for a sphere? Radius. So that becomes at the surface, no? This is the radius of the sphere that you will be considering. Outside, it will be smaller, whatever value will be there. At the surface, it will be radius. And see, if let's say I have taken some point inside. See, inside for a hollow sphere, inside intensity will always be zero. Remember, for hollow sphere, always intensity is zero, not solid. That's why I've mentioned hollow sphere. Even if you plot a graph, no? Even if you plot a graph, this is intensity, R is equal to at the surface, R is zero. Here, R is less than capital R, that is inside. See, R is equal to 0 means that exactly at the center. R is equal to R, where it is the radius, that is exactly at the surface. So between the center and the surface, this is inside. This I had discussed in the last class as well. And any point greater than the surface radius, it is outside. Now see, for inside, entire portion within inside, this will be 0. So see, this entire part, it will be 0. And suddenly, and then for surface, you have a value, and outside it is inversely proportional. So even if you get graph plotting, mark it like this only. Clear? Like this, you have to plot the graph for it. So this is for hollow sphere. If you want to calculate it for solid sphere, see, for solid sphere, now I'll tell you the formula. You can calculate it by density, mass by volume, you can say, and calculate it using density. See, if it is secondly for solid sphere, all these above portion were for hollow sphere only. Center, radius is 0. Inside, 0. Surface, radius will be r. Outside, radius will be smaller. For solid sphere, no, if you are calculating for, let's say, P point outside, this is small r, this radius is capital R, mass is m. For outside, it will be gm by r square only. Same thing for solid sphere. If you are calculating it exactly at the surface, so surface, this is also same. For the surface, it will also be gm by r square. But if you are calculating it inside, this time it won't be 0. It will be gm by small r divided by r cube. This is all about the sphere. Intensity of spheres if you have to calculate. Also, one more thing. If you are calculating at the axis of it, axis of a ring. You're calculating intensity at the axis of ring. Let's say you have ring. Third case, let's say ring. So I'm keeping it in XZ plane like this. This is the radius R. And at this point, I'm calculating. This point P, mass is M of the ring. So on the axis of ring, this will be GMR by R square plus small r square to the power 3 by 2. Now see, at the center, what will happen? Exactly at the center of the circle, small r will be 0, right? Because this will reduce to here, so separation will be 0. As soon as r becomes 0, I will also become 0. So at the center, it will be 0. Fine, these are some applications of this gravitational field intensity. Note down this part. Any doubts you have, class, get it clear.